All right, we're going to do a bunch of homework problems from homework 3. Now, this first one says, which of the lines in the following graph appear to be tangent lines? Well, what about L1 here? No, L1 does not appear to be a tangent line, right? It's kind of cutting through the curve rather than being tangent to the curve. So L1 does not. L2 does look like it's a tangent line, right? Notice the line is kind of hugging the curve right there. It has the same slope as the slope of the curve at that point. And same thing with L3 and L4. Those all look like they're tangent lines. Now, not L5. Right, so L1 and L5 are not tangent lines. L6 does look like it's a tangent line. You might have to zoom in a little bit. But yeah, so all of them look like it except for L1 and L5. So down here, we'll click all of these except L1 and L5. Check our answer. There we go. Now, this next one asks us to estimate the slope of the tangent line to the curve at the given point. So here's our curve, and we have a tangent line right here at this point 3. What is the slope of the tangent line? Now, we have to look at the scale on the axes here. So every tick mark is 1, and every tick mark here is 1. So the question is, what is the slope of this line? Well, it certainly looks like the slope is less than 1. In fact, the slope of 1/2 looks reasonable, right? So if we go over 2, let's say, and go up 1, yeah, that looks like a slope of 1/2. So let's put 1/2. Now this one looks much easier here. Estimate the slope of the tangent line of the curve. So here we have our curve, and we're looking at x equals 0 here. We're looking at what is the slope of that line. Well, a horizontal line has a slope of 0, right? The tangent line there is a horizontal line, so it has a slope of 0. Okay, now number 4, it's asking us to find f prime of x, which is the derivative of f of x, if f of x is 6x to the ninth. So what's the derivative of 6x to the ninth? Now, the easy way to do this is to recognize that f prime of x, the way to find it is you're just going to take this 9 and multiply it by 6. So 9 times 6 is 54 times x to the, and then you're going to lower this power by 1, x to the 8th. It's going to be 54x to the 8th. Another way to kind of think about this is that f prime of x, since this is really a constant times a function, right? 6 is a constant. The derivative of a constant times a function is just the constant times the derivative of the function. But what's the derivative of x to the ninth? Well, it's 9x to the 8th, right? That's the power rule. So 6 times 9x to the 8th, that ends up being 54x to the 8th. Okay, but I think this way down here, just multiplying the 6 times the 9 and then lowering that power by 1, that's the quicker way to do it. Okay, now this one, what is f prime of x if f of x is negative 3x to the 7th? Well, notice, take the 7 times negative 3, that's negative 21, x to the what power? Well, we got to lower the 7 by 1 when we get 6. Okay, negative 21 x to the 6. Let's check our answer. What about this one? This is asking us for f prime of t if f of t is this. So here we're using t instead of x, but that's okay. In fact, here's our function f of t equals this. What is f prime of t going to be? Well, f prime of t, well, the derivative of 5t cubed is going to be 15t squared, right? We bring the 3 out front. 3 times 5 is 15. And then we lower this power by 1, 15t squared. Now, what's the derivative of 2t? The derivative of 2t is just 2. You could think of it as like 2t to the 1 here, and then 1 times 2 is 2, and then it's 2 times t to the 0 power, but t to the 0 is just 1. Right? So whenever it's just like 2t or 2x or something like that, the derivative is just going to be 2. Or if it were 7t, the derivative would be 7. Now, the derivative of a constant, the derivative of 3, is just 0. And usually we don't even write that 0 on the end there. So the derivative is going to be 15t squared plus 2. (15t squared plus 2). Okay, now what about this one? Now, this notation is a little bit different. It says, what's d dx, or find d dx of this? This is just another way of saying find the derivative of this function. Now, it might be tempting to say, well, let's just take the derivative of the top and divide it by the derivative of the bottom. And the derivative of the top is 8x to the 7th, and the derivative of 16, derivative of a constant, is 0. So it's going to be 8x to the 7th over 0. But that's not correct. Remember that the derivative of a quotient, right, when you're dividing things, is not equal to the quotient of the derivative. So we can't just do the derivative of the top divided by the derivative of the bottom. So how do we do this one? If it's not 8x to the 7th over 0, how can we do this one? Well, what we're going to do is rewrite this. When you're dividing by 16 down here, it's the same thing as multiplying by 1/16. So this is the same thing as 1/16 times x to the 8th. And what's the derivative of 1/16 times x to the 8th? Well, again, we can take the 8 and multiply it out front. So we get 8 times 1/16. That's really 8/16 times x to the 7th power. Remember, you lower that by 1. By the way, I'm getting rid of the d dx now because I'm actually taking the derivative, right? This says the derivative of this is the same thing as the derivative of this, right? This is just another way of rewriting this. And what's the derivative of this? Well, we take the 8 times 1/16, that's 8/16 times x to the 7th. Now, 8/16 is really just 1/2. So we can write this as 1/2 x to the 7th power. Or you could write it as x to the 7th over 2. Okay, that would be another way of writing it. Let's write it as 1/2 x to the 7th power. Okay, again, it would also accept x to the 7th divided by 2. What about this one? Find h prime of t if h of t equals this. And notice we have a polynomial here in t, so not in x, but a polynomial in t. And we have some decimals. So I've written it here. What is h prime of t? Well, the derivative of 12.8 is just 0. Remember, the derivative of a constant is 0, so we don't even need to write the 0 here. But then what's the derivative of 5.6t? Well, it's just 5.6. Remember, the derivative of a constant times just t or just x is just going to be that constant. Minus, now what's the derivative of this? Well, we can take the 2 and multiply it by the 1/2, the 0.5, and get 1. So this is just minus 1 t to the, well, if you lower 2 by 1, you get t to the 1 power. Okay, so in other words, this is just 5.6 minus t. Okay, 1 t to the 1 is another way of saying t. So 5.6 minus t is our answer. All right, what about this one? If g of w equals this, what is g prime of w? What's the derivative of this function? Now here, our independent variable is not x or t, it's w. And by the way, our original function here, we're not calling it f, we're calling it g. Okay, but what's g prime of w? Well, the derivative of 9w to the 7th is going to be 63w to the 6th, right? 9 times 7 is 63, right? 63w to the 6th. And then plus 16w to the 1, right? The derivative of 8w squared is going to be 16w to the 1. We don't have to put the to the 1, though. Plus, well, what's the derivative of 11w? It's just 11. Check our answer. There we go. Okay, this next one says, let g of x equal x cubed plus 5x. Find g prime of x, and then use that to find g prime of 1. Now, this one's actually pretty simple to do, but I want to give a geometric understanding of what this g prime of 1 means as well. So g prime of x, right, if we want to find g prime of 1, we need to find g prime of x. That's going to be 3x squared plus 5, right? Derivative of x cubed is 3x squared, derivative of 5x is 5. That's g prime of x. What's g prime of 1? Well, what we need to do now is plug in 1 into our formula for g prime of x. So by the way, we're not asking what's g of 1. To find g of 1, you just plug 1 in here, and I think you get 6 as a result. But what is g prime of 1? Well, you get 3 times 1 squared plus 5. That would be 3 times 1, which is 3, plus 5, which is 8. Okay, so g prime of 1 is 8. So g prime of x was 3x squared plus 5, and g prime of 1 was 8. So that's actually answer D. It almost looks like it's A, but notice that says plus 5x, right? It's 3x squared plus 5, and then g prime of 1 is this. We're going to check our answer, but then let's also go to Desmos real quick. Notice this one, by the way, g of 1 is 6. So let's actually put in the ordered pair 1, 6 on the graph here. So if you were to plug in 1 for x, you would get 6. So g of 1 is 6. Here's 1, 6. What is the slope of the tangent line there? Okay, what is the slope of the tangent line there? That's what g prime of 1 is asking us. So when we say what's g prime of 1, we're asking us how steep is the curve there? What's the slope of the curve there at that point? So the height of the curve, right? How high is the point above 1? That's at a height of 6, but the slope there is actually 8. It has a steepness or a slope of 8 there. In fact, you can even plug in what's g prime of 1 here. It actually shows you g prime of 1 is 8. Okay, so this is the point 1, 6, but the slope of the tangent line there is 8. All right, now what about this one? Find the value of the derivative. And it's asking us for finding dy dx, and that's just another way of saying y prime, or the derivative. Now, this vertical bar means evaluated at x equals -5. Okay, so what's the derivative at -5? So if this were f of x instead of y, so we're calling it y equals 1 minus 2x squared, but if we're f of x, this would be like the same thing as saying, what's f prime of -5? Okay, what's the derivative at -5? So we're writing it dy dx evaluated at -5. So here's our y of x. Now, what is dy dx? Well, the derivative of 1 is 0. The derivative of -2x squared is going to be -4x to the 1, right? We have to lower that power by 1. We get 1. 2 times -2 is -4. So dy dx is -4x. What's dy dx evaluated at x equals -5? Well, what we need to do is take our formula that we just found here, this formula here, and plug in -5. So we get -4 times -5, and that's +20. Okay, so that tells us the slope of the tangent line of this curve here, 1 minus 2x squared, when we're at x equals -5 is 20. Okay, so the value of the derivative here is 20. We're going to look at this on Desmos as well. Here's the graph of 1 minus 2x squared here. Now, the point, if you plug in -5 for x, what you're going to get, -5 squared is 25, positive 25 times 2 is 50. 1 minus 50 is -49. So actually the point -5, comma, -49 is going to be on the graph. In fact, we have to zoom out to really see that point. It's way down here. Right, there's the point. Let me label it here. There's the point -5, comma, -49. So when we're at x equals -5 here, and this would be the point on the graph, -5, -49, what is the slope of the tangent line? How steep is the curve there? Well, it turns out it's a very steep curve there. In fact, what's the slope there? The slope was 20. Remember, we found that the slope of the tangent line there is 20. Okay, so when we plug in -5 into y, we get -49. But when we plug in -5 into y prime, right, or into dy dx, we get 20, positive 20. That's the slope of the tangent line. Now this one says, using the definition of derivative, find f prime of x. Okay, then find f prime of 1, f prime of 2, and f prime of 3 when the derivative exists. And it gives us the function here. Now, there's a very simple way to do this without using the definition of derivative. And it's okay if you do it that way, but I want to kind of show you both ways. So I want to show you doing this using the definition and also not using the definition. So here's our function, -x squared plus 5x minus 9. The question is, what's f prime of x? And then what's f prime of 1, f prime of 2, f prime of 3? Okay, well, we know these derivative rules, right? And f prime of x, what's the derivative here of this function? Well, the derivative of -x squared is going to be -2x to the 1, right? Plus the derivative of 5x is just 5, and the derivative of minus 9 is just 0. So f prime of x is -2x plus 5. So that's actually the answer to the first part. That's really easy. Notice, what's f prime of 1? Okay, well, f prime of 1 is -2 times 1 plus 5, which is really just -2 plus 5. That's 3. Okay, what's f prime of 2? Well, we do -2 times 2 plus 5. And that's really -4 plus 5. That's 1. And what's f prime of 3? Well, it'd be -2 times 3 plus 5. That'd be -6 plus 1. That's -1. Okay, so our answers are -2x plus 5, and then f prime of 1 is 3, f prime of 2 is 1, and f prime of 3 is -1. So this is the easy way to do it here, is what I'm showing you. I'm not using the definition of derivative. Okay, so we get -2x plus 5. What's f prime of 1? Well, the derivative does exist, so we're going to put a, not b here. F prime of 1, right, when we plugged in 1 here, we ended up getting 3 as a result. F prime of 2 was 1. And f prime of 3 was -1. Okay, that was kind of the quick way of doing this problem, where we didn't use the definition of derivative. We just knew how to take the derivative of this. We found what the derivative was. We'll look at the definition of derivative in just a second, but let's also look at the graph of this function. So here we are in Desmos. We have f of x equals, well, this is our function. Notice it's a parabola. And notice, by the way, that f of 1 is -5. So what that really means is that the point 1 comma -5 is on the graph, and you see it right there. F of 2 is -3, and so the point 2 comma -3 is on the graph. Make all those blue. And f of 3 is -3. So 3 comma -3 is on the graph. And let me label each of those points. A question we could ask, though, is what is the slope right here at 1? Okay, what's f prime of 1? So f of 1 was -5. What's f prime of 1? F of 2 was -3, and f of 3 was -3. But what's the slope there? Notice it looks like it has a positive slope right there. That looks like it's a negative slope right there, right? This looks like it's a little steeper positive slope than we have right here. In fact, if we draw in the tangent line, the question is, what is the slope of the tangent line at various points? So at this point 1 comma 5, what is the slope of the tangent line? In fact, I've drawn in the tangent line. Notice it looks like it's a slope of 3, right? This black line, if you go over 1, you go up 1, 2, 3, has a slope of 3. And didn't we find that the slope there was 3, right? F of 1 is -5, but f prime of 1 was 3. Now, what about right here? What's the slope of the tangent line there at 2? Well, the slope there is 1. Notice this black line has a slope of 1. Every time you go over 1, you go up 1. Every time you go over 1, go up 1. What about when we're at 3? Well, now, again, f of 3 is -3. What's f prime of 3? What's the slope of the tangent line? The slope is -1, right? If we go over 1, we go down 1. Over 1, down 1. The slope there is -1. By the way, in case you're very curious, like, how did I put in the tangent line here? Don't worry too much about this. I made what's called a slider for C, and C is kind of like your x1, and you can kind of slide this back and forth to make this tangent line. And so I labeled the point C comma f of C, so that's this point right here that's moves. Now, what about the tangent line? Well, I used essentially like y minus y1 equals m times x minus x1, where my x1 is just C, and my slope is f prime of C. So again, if that doesn't make sense, don't worry about it. But just in case you were curious, like how did I come up with this tangent line here? You want to try it on your own, let's say. This is how you do it. Okay, but how would you use the definition of derivative to find the derivative of this function, right? We found the derivative using the rules, and then we found f prime of 1, 2, and 3. We found it as these values here, these slopes. Well, remember that f prime of x, the definition of f prime of x is it's the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so we're going to rewrite this for our particular function that we have. We have the limit as h approaches 0 of, and we're going to put a big line right here. What is f of x plus h and what is f of x? Well, f of x, we're going to put minus our f of x. Our f of x is just this. It's negative x squared plus 5x minus 9. And we're going to put it in parentheses because we're subtracting the whole f of x, not just that first term here. So minus our f of x. So this is the f of x. Now, the question is, what is f of x plus h? Well, we need to take this formula and plug in x plus h everywhere we see an x. So instead of having negative x squared, we're going to have negative x plus h squared plus 5 times, instead of times x, it'd be times x plus h minus 9. So we're basically taking this formula and replacing each of these x's with x plus h. So all of this right here is the f of x plus h. Now we're going to have to simplify things. Notice that x plus h squared is the same thing as x plus h times x plus h. And x plus h times x plus h, if you FOIL it out, it ends up being x squared plus h squared plus 2xh, right? If you write out x plus h times x plus h. But we have a negative in front of it, so it's really negative this. Then we have a plus 5x plus 5h, right? We distribute the 5 there. We have a minus 9. Then minus minus is going to be plus x squared. And we have a minus 5x. We have a plus 9. Now notice we get some nice cancellation. The 9 and minus 9 go away. We have a minus 5x and a plus 5x that go away. We'll have some other things cancel as well, but let me distribute this negative first of all. We have a negative x squared minus h squared minus 2xh. And we still have this plus 5h and plus x squared all over h. So we still have these two terms. Now notice the x squared and minus x squared are going to go away. So notice we have three terms left in the numerator. Each of these terms has an h in them. So let's go ahead and factor out the h. We have a limit as h approaches 0 of, well, let's factor out the h and see what we're left with here. We have negative h times h would give you negative h squared. We have a minus 2x times h is minus 2xh, and then plus 5. Okay, we factored out of h from each of these terms, and this is what we get. Now notice if we plug in h, 0 for h, actually at any step along the way here, we're going to get 0 over 0. But once we cancel these h's, we can cancel these two factors. Now we can just plug in 0 for h because we're not going to be dividing by 0. In fact, now if we take the limit as h approaches 0, now remember, this is not the limit as x approaches 0. This is the limit as h approaches 0. So we plug in 0 for h, and notice what we get. Well, if we plug in 0 there, that just goes away, and we end up getting negative 2x plus 5. And isn't the answer, the same answer that we found when we did the rules, negative 2x plus 5. In fact, notice way up here, the derivative was negative 2x plus 5. We just found that out using the derivative rules. That was so much easier, right? But really, where do those derivative rules come from, right? It comes from this long process here. So if we want to find f prime of x using the definition of derivative, and this is the definition of derivative, we go through this long, laborious process, and we end up getting, if we do everything correctly here, we end up getting this negative 2x plus 5. But that's exactly what we found in just immediately, like in one step. So this problem, you don't have to do all this mess down here of using the definition of derivative, but I think it's a good thing to know how to do. And it also shows how limits are used, right, in the definition of derivative. In fact, at any point in here, if we just plugged in 0 for h, we would end up getting 0 over 0 until we get to this point where we cancel the h's. Now, when we plug in 0, we're not dividing by 0, but we get our final answer. By the way, there's another problem later on here. Use the definition f prime of x equals this to find the derivative of this at x. Well, you don't need to use the definition. If you want to just use the rules, that's fine. In fact, what is the derivative of this? Well, the derivative of 3 is 0. The derivative of negative 6x squared. This is just going to be negative 12x, right? Okay, in fact, that's the answer right there. That's f prime of x. If you could go through that big, long process that we just did, find the derivative using the definition, but this is just much quicker using the rules. In fact, you see the usefulness and the value of those derivative rules. Okay, now this one, let f of x equals this. Find f prime of negative 3. Well, what you need to do on this one, it's pretty simple. Just find f prime of x, so take the derivative of this, and then plug in negative 3. Okay, and you should get one of these answers. And really, the same thing for 25. Let f of x equal this polynomial here. Find the slope of the tangent line at x equals negative 2. Well, what this is really asking you to find is what's f prime of negative 2. So not f of negative 2, right? We don't plug in negative 2 here. We find f prime of x. So we take the derivative of this function, right? So it'd be 4x cubed plus 18x squared plus 2. And then into that, so that'd be f prime of x, we find f prime of negative 2 by plugging in negative 2 into the derivative. And you're going to get one of these answers. What about this one? Find all values of x, if any, where the tangent line to the graph of the function is horizontal. Now, what it means to have a horizontal tangent line, right? That means a tangent line that has a slope of 0. So is there anywhere on the graph of this function where the slope is 0? The slope of the tangent line is 0. Okay, so here's our function. Well, what is f prime of x? F prime of x is 2x plus 2. Okay, now we're not trying to find what's f prime of 0, we're not the slope at 0. We're trying to find what value of x makes the slope be 0. So in other words, I'm not going to do f prime of 0. I'm going to set f prime of x equal to 0. And we're going to solve this for x. In other words, what input here would give us an output of 0? Well, notice if we subtract 2 from both sides, we're going to get negative 2 equals 2x. And so x is negative 1. Divide both sides by 2. move it down, divide both sides by 2, and you get x equals -1. So in other words, we have f prime of x is this. What would be f prime of -1, right? If we plugged in -1 here, well, it'd be 2 times -1 plus 2. That'd be -2 plus 2, which is 0, right? So notice that it's at -1 that we have a slope of 0. In fact, we can go into Desmos and see, notice, here's our function. Where is the slope 0? Well, notice, isn't it at -1, the place where the slope there is 0? Now, f of -1 is -4, but f prime of -1 is going to be 0, right? See, notice the slope of the tangent line. It's a horizontal slope, right? At different places along the curve. Different places along the curve, we're going to have different slopes. But when we're at -1 right here, that's when the slope is 0. So find all values of x, if any, where the tangent line to the graph of the function is horizontal. Well, it's at -1. A similar thing here. Find all values where the tangent line to the graph is horizontal. So we'll take the derivative and set it equal to 0. Notice here we're calling it y instead of f of x. So we can put y prime or dy dx, however you want to write it. Dy dx or y prime is 3x squared minus 12. And we're trying to find what value of x makes that be 0. So we're trying to solve 0 equals 3x squared minus 12. And notice we could factor out the 3 and write this as 3 times x squared minus 4. And we can actually factor this as 3 times x plus 2 times x minus 2. So notice the values of x that are the solutions are x equals -2 and x equals 2. Those are the values that will make this equal to 0. In fact, notice if you plug in 2 here, 2 squared is 4, times 3 is 12, minus 12 is 0. Or if you plug in -2, right? -2 squared is positive 4, times 3 is 12, minus 12 is 0. So the tangent line is horizontal, in other words, has a slope of 0 at x equals -2 and x equals 2. In fact, you can see that in Desmos. Here's our curve. Now, it's a little hard to see here, but at 2, and at -2, at these 2 points, 2 comma -14 and -2 comma positive 18, those are the places where we're kind of at the top of the hill here, right? Where the slope is 0. And also down here, the slope is 0. So at 2 and -2, those are the places on our curve where we have horizontal tangent line. Now this one says find the values of x for which the slope of the curve y equals f of x is 0. So find the values where the slope of the curve is 0. And then part B, find the values of x where the slope of the curve is 28. Well, part A is like what we've just been doing. So where is the slope 0? Where do we have a horizontal tangent line? Well, we'll do the same thing we did before. So we're going to take the derivative, set it equal to 0. Part B, we're going to take the derivative and set it equal to 28. Okay, so f prime of x is 4x plus 8. And now we're trying to find what input for x would give us an output of 0, right? A slope of 0. So we're going to solve this for x. So in other words, we're not trying to find f prime of 0. F prime of 0 would be 8, right? If you plugged in 0 there, that would be 8. F prime of 0 is 8. So at 0, the slope of the tangent line is 8. The question is, at what x value is the slope of the tangent line 0? So we need to solve this. Well, if we subtract 8 from both sides, we end up getting -8 equals 4x. Divide both sides by 4. And we get x equals -2. So it's at -2 where we have a slope of 0. Now, where do we have a slope of 28? Well, we have our derivative here, but instead of setting it equal to 0, we're going to set it equal to 28. So we'll set 28 equal to 4x plus 8. If you subtract 8 from both sides, you're going to get 20 is equal to 4x, and so x is equal to 5. Okay, so at x equals 5, the slope of this curve is going to be 28. That's actually a very steep slope. It's going to be a slope of 28. So at -2, the slope is 0. At 5, the slope is 28. Slope of the curve is 0 at x equals -2. And the slope of the curve is 28 at x equals 5. All right, now what about this one? Find the slope of the function's graph at the given point. then find an equation for the tangent line to the graph there. Okay, so we're trying to find not just the slope of the tangent line, but an equation for the tangent line there. So our function is x squared minus 3, and we're going to look at the order pair minus 5 comma 22. So notice here's x squared minus 3. You can see the graph. It's really this parabola x squared only shifted down 3, right? There's x squared minus 3. And we have this order pair minus 5 comma 22. So they weren't really kidding us. The minus 5 comma 22 really is in the graph. In fact, you can see that. What is f of minus 5? So f of minus 5 is 22, right? You could plug in minus 5. Minus 5 squared is positive 25, and then minus 3 is 22. So they're not kidding. Minus 5 comma 22 really is on the graph. Now the question is, what is the slope of the tangent line there? And notice it looks like a negative slope. And not only what is the slope of the tangent line there, what is an equation for the tangent line there? Okay, to find the slope of the tangent line at negative 5, we just need to find f prime of negative 5. Well, f prime of x is just 2x. Derivative of this is 2x. F prime of negative 5 is 2 times negative 5, which is negative 10. So the slope of that tangent line was negative 10. Now, how do we find the equation of the tangent line? So the slope of the line going through this point is going to be negative 10. How do we find the equation of the tangent line? Well, to find the equation of a line, if we know the slope of the line and one point on the line, and we have a point on the line, minus 5 comma 22, we can find the equation of the tangent line using the point slope formula. So let's remind ourselves we have y minus y1 equals m times x minus x1. Now, this point up here, this is going to be our x1, y1. This is a point on our graph. And make sure you plug this in, these values, minus 5 and 22, for x1 and y1. Don't plug them in for x and y. Now, what is the m? What is the slope? Well, the slope is this negative 10, right? The m is the negative 10. So our final answer is going to be y minus y1, but that'd be y minus 22, equals negative 10 times x minus a negative 5. Now, I think it wants us to put our final answer in the form y equals mx plus b. So let's simplify this a little bit. We have y minus 22 equals, and this is really negative 10 times x plus 5. X minus a negative 5 is x plus 5. And then let's distribute the negative 10. So we get negative 10x minus 50. And finally, let's add 22 to both sides. And we get y equals negative 10x. Well, let's see, negative 50 plus 22, I believe, is negative 28. So that is the equation of our tangent line, negative 10x minus 28. Okay, y equals, this is of the form y equals mx plus b, right? Y equals negative 10x minus 28. In fact, let's check this here. Y equals negative 10x minus 28. Notice that certainly looks like it's a tangent line to the graph at that point, minus 5 comma 22, right? That's the equation of the tangent line is negative 10x minus 28. That's the equation of this line. So let's go answer the question. What is the slope of the function? Well, wasn't it negative 10? Okay, so the m is negative 10. That's really, again, just what is f prime of negative 5, right? F of negative 5 was 22, but f prime of negative 5 was negative 10. And our final answer ended up being negative 10x minus 28. By the way, there's several other questions like this. For this, find f prime of x. So you take the derivative, that's pretty simple. Find the slope of the graph at negative 1. So you'd find f prime of negative 1. That would be part B. And then find the equation of the tangent line at negative 1. How do we do that? Well, in the one that we just did, it gave us an ordered pair. It gave us minus 5 comma 22. This one is not giving us an ordered pair. So how do we come up with our ordered pair? Well, if you plug in negative 1 into your original function f, I think you'll get something like negative 1 comma 14 or something like that. That's the ordered pair on the graph. And once you have the slope and that ordered pair, you use the point slope equation, and then you simplify it to get your final answer in the form y equals mx plus b. Now, part D, find the values of x where the tangent line is horizontal. Well, that one is like ones that we previously did as well. You just take that derivative that we had and set it equal to 0, and you solve for x. So you probably need to factor it or something, and you solve for x. Okay, a similar thing on this one. Find the equation of the tangent line at x equals 7 for this function 6 minus x squared. Then you write your answer in the form y equals mx plus b. So notice, first of all, what is f of 7? Well, you find f of 7, it'd be 6 minus 49. So it'd be like negative 43 or whatever that is. And then you need to find f prime of 7, okay, to find the slope. So f prime of x would be negative 2x. And you find f prime of 7, so it'd be like negative 14. And then you use the point slope equation and simplify it, and you should get one of these answers. You can check your answer on Desmos to see if it looks any of these look reasonable. Now we're going to finish looking at a few problems where we talk about whether a function is differentiable or not. So list the x values in the graph at which the function is not differentiable. So a place where the derivative doesn't exist, right? Well, notice in this one, we have a sharp corner right there. There's no tangent line there. We have tangent lines at every point along this graph except this sharp corner here. Now, if it were rounded off at the top, if we didn't have a sharp corner there, then it would be differentiable there. We would have a nice tangent line. But notice it's at x equals 0. Okay, so not way over here at x equals negative 2, negative 1. It's at x equals 0 where it's not differentiable. Okay, on number 36, we have these sharp corners here at negative 2 and also at 2. Right? So at negative 2 comma 3 there and 2 comma negative 3, right? So at negative 2 and 2, the function is not differentiable. What about here? It's asking us to find all the places where the function is not differentiable. Okay, now at x sub 0 here, the graph is differentiable, right? It's a nice smooth curve there, right? We would have a nice tangent line right there, so it's differentiable. Well, x1 is not differentiable. We won't have a tangent line. In fact, it's not even defined there. Remember, a function has to at least be continuous at a point in order for it to be differentiable there. It's not continuous at x1 because the function isn't even defined at x1. So here's a place where it's not differentiable. Same thing with x2. We don't have a tangent line there because the graph isn't even continuous there. Okay, the function isn't continuous there. So x2 is a place where it's not differentiable. x3 is also not differentiable because we have that sharp corner. Now, it is continuous at x3. Okay, it's continuous at x3, but it's not differentiable. Remember, differentiability is a stronger condition than continuity. You could have a place where it's continuous, but it's not differentiable, like if you have a sharp corner there. Or if you had like a vertical tangent line. I guess if the tangent line were infinite slope, okay, it would also be not differentiable. The derivative would not exist there. So x3 is another place where it's not differentiable. x4 is not differentiable because it's not continuous. But x5 is perfectly fine, right? There's nothing wrong with the function there, right? It's a nice smooth curve there. We have a nice tangent line. So at x0 and x5, we have nice tangent lines. But all the other ones, they're places where it's not differentiable. Okay, now what about this one here? Is this one differentiable everywhere? Or is there any place, list the x values in the graph at which the function is not differentiable? Well, notice it's a nice smooth curve. At every point, we have a nice, well-defined tangent line, and there's no place where the slope is infinite or the function is not defined, it's not continuous. So yeah, this is differentiable at all points. Okay, what about this one? We got a lot going on here. List the points in the graph in the interval -1 to 6. So if we're between -1 and 6, so we're not including -1 itself or 6 itself because we're the open interval here, really, between -1 and 6. At which points is the function not differentiable? Okay, well, notice it's nice and smooth right here. We might have a problem at the left endpoint at -1, but again, we're not concerned with -1 or 6. X is strictly bigger than -1 or less than 6. So notice we have a problem though at 1. At x equals 1, it's not differentiable. Everything's okay here, but then we have a problem at 3. Right? It's not even continuous, so it definitely can't be differentiable. And same thing at 5. It's not even continuous there, so it's not differentiable. So we have problems at 3 and 5. The function's not even continuous there, but we also have a problem at 1, right? Because even though it's continuous, it has a sharp corner there. So there's no nice, well-defined tangent line there. So how do we write this one out? The function is not differentiable at, and it says use a comma to separate answers as needed. So it was 1, 3, and 5. those were the places where it was not differentiable. Let's check our answer. And there we go.